to simplify radical expressions that have coefficients and multiple variables, we'll always handle the coefficients first and then the variables in alphabetical order. The index here is not included, so we can assume it is a 2. The same thing here, there's no index included, so we'll assume it is a 2. Here the index is 3. So in this first example, 81x to the 4th, we're looking for the square root of that. So I'm looking for a set of two factors that multiply together to equal 81x to the 4th. They have to be squares. So 9 times 9 is 81. So 9 will be the coefficient of each of those two factors. And x squared times x squared would get you x to the 4th. Again, 9 times 9 is 81. X squared times x squared gets you x to the 4th. So the square root of 9x squared would be 3x. Right? If we wanted to look at that this way, the square root of 9x squared would be 3x. And the square root of 9x squared would again be 3x. So when we take 3x times 3x, we get 9x squared, which is again the repeated factor that's underneath here. So if you wanted to double check this, we would always take the number outside, or the number that we solved for, 9x squared, and raise it to the power of the index. So we take 9 squared, or 9 times 9 is 81, and x squared squared would be x squared times x squared, which would be x to the 4th, and that's what we have inside our original radicand, so we know we're correct. Now in this one, we don't have a coefficient, but we have multiple variables. The key here again is that the index is 2, so we are looking for groups of 2 factors that make this number up. So when we're looking at x to the 10th, we're really looking at x to the 5th times x to the 5th. When we're looking at y to the 8th, we're really looking at y to the 4th times y to the 4th, because we're looking for 2 groups. We have 2 groups that multiply to our x of 10. We have 2 groups that multiply to our y of 8. And we're going to have 2 groups that multiply to our z. And they're each going to be to the first power to equal a total of 2. So if we have 2, our index is 2, we need 2 of these to take one of them out, so that's going to be an x to the 5th. We need 2 of these to take one of them out, that's going to be a y to the 4th. And we need 2 of these to take one of them out, that's going to be a z. So we have x to the 5th, y to the 4th, z. We should always check these to make sure that we're right by raising this number to the power of the index. So x to the 5th squared is x to the 10th. Y to the 4th squared is y to the 8th. And z to the 1st squared is z to the 2nd. So x to the 10th, y to the 8th, z to the 2nd. That was my original radicand, so I know I'm correct. Last one down here. The index is 3, so we're looking for a cubed root. So we're looking for 3 factors that multiply to get us each of these things. So 3 factors that multiply to 27, well, that's 3 times 3 times 3. 8 to the 6th, I'm looking for 3 things that multiply to 8 to the 6th, and they have to be the same. Well, that's 8 to the 2nd times 8 to the 2nd times 8 to the 2nd. Again, in each of these, I'm looking for 3 groups because that's what my index is. So now 3 that multiply to b to the 9th, so that's going to be b to the 3rd, b to the 3rd, and b to the 3rd. 3 factors that multiply to 9. And then finally, a c to the 3rd, it's going to be 1, 2, 3. So a c to the 1st, c to the 1st, and c to the 1st. So for each of these groups of 3 factors, I can take one of them outside the radical. So I have 3 factors of 3, so that means I can take one of them out. 3 factors of a squared, so I can take an a squared out. 3 factors of b to the 3rd, I can take a b to the 3rd out. And I have 3 factors of c to the 1st, so I can take a c to the 1st out. So the cube root of 27, a to the 6th, b to the 9th, c to the 3rd is 3a squared b to the 3rd, c to the 1st. If I want to check that, I can always raise that to the power of the index and see if I'm right. Well, 3 to the 3rd power is 3 times 3 times 3, which is 27. A squared to the 3rd power is a squared times a squared times a squared, which is a to the 6th. b to the third power is b to the third times b to the third times b to the third, which is b to the ninth. And c to the first times c to the first times c to the first is c to the third power. So 27, a to the sixth, b to the ninth, c to the third. That was my original radicand, so I know I have done this correct.